All right, this is Math 209, Week 4, Section 11.3. We're solving equations by completing the square, and you have no idea what that means, so let's get started on that. So the idea is we want to be able to factor this equation right here, okay? Now, when we try and factor this equation, the old way, right? So the idea would be, let's make a box. So it's, oops, let's go up here and say, okay, so this is x squared plus 18x, what was it? Now it said minus 7, but if we add 7 to both sides, that's going to create, up here, it's going to create plus 7 equals 0. And the idea is, okay, let's use the box to factor that equation, right? So we're going to create the box. And we know that x squared goes here, we know 7 goes here. And then when we try and keep going, there is no way we know how to solve this equation. We just don't know how to do it. We can't. So what we're going to do is we're going to do a little trick to how to how to factor this and how to solve it. And it's called completing the square. All right. Now what completing the square means is, and I can delete that little thing because I don't need it anymore. All right. So what that means is we've got for 18 x squared plus 18x. So this guy stands for x squared. So there's an x squared. And we need 18 of these guys. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've got 18 of them, all right? These stand for the x's, all right? So what I'm going to do is I'm going to create a square with these pieces. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take those 18 and I'm going to take half of them and I'm going to put them down here like this, and then the other half, oh boy, this is going to be tricky. The other half, I'm going to take them over here and rotate them. Will it let me rotate? Yes, it will. There, boom. And actually, I'm going to just kind of cheat here. I'm going to take that guy, and that's 1, and then 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my figure, all right? So all of these were actually, we can make those go away, all right? So because we don't need those anymore. All right, so, my phone. So I've got this figure that sort of looks like the beginning of a square. That's why it's called complete the square. So now the question is, how many of these little tiles do I need in order to fill in this grid? Well, I've got 9 going this way. There's 8 and 7, 8 and 9. So I've got 9 going this way. And then I've got 9 going this way. So how many of these little squares do I need in order to fill in this big gap right here? So how many do I need? Well, 9 by 9, so that's 81. So what do we have here? So what we've got is, here is our x squared. Here's 9x, and here's 9x. And then inside here, I've got 81 individual tiles, all right? So when we go back to the equation, which was x squared plus 18x, and then it's going to be equals negative 7, okay? So if I want to take that x squared, yeah, let's see if I can move that. I can. Rockin'. All right, so if I want to take that x squared plus 18x, and I'm going to create a square with it. Well, I'm going to have the x squared in the upper left-hand corner. Half of these guys are going to go across. The other half are going to go down. And then that's going to tell me, oh, well, half of 18 is 9. And so now I need to add in 81 extra little tiles here. Now, specifically, what is 81? Well, 81 was 9 squared. How did we get 9 squared? We took 18 and we divided by 2. So we take the 18, we divide by 2, that gives us 9, and then we square it. So what are we going to add to both sides? Well, if I needed to add 81 to this side to complete the square, well, that means I need to add 81 to the other side. Otherwise, my balance will not be balanced anymore, because whatever you add to one side, you have to add to the other to keep it balanced. So moving over here, what are we going to add to both sides of the equation? We're going to add 81. Now the big trick, how did we get that? We took the 18, we divided by 2, and then we squared it, and that's how we got 81. So here, completing the square, we just learned what we're going to do. So you're going to take your x squared minus 3x. We're going to create a little gap here, and there's our 1. And so what we're going to do is we're going to take half of 3. So if you think about half of 3, that's 3 divided by 2. And then we're going to square it. And when we square it, we get 9/4. So that is what we are going to add to both sides of our equation. 9/4. And so that's what you're going to put right here. 9/4. You do not need to change 9/4 into 2 1/4. You don't need to do that. We're just going to leave it as 9/4. So what's the trick? You might need to write yourself a recipe for completing the square, which is take this number, this x number, and you have to cut it in half. So you divide by 2. In this case, we're just going to leave it as a fraction because it's not a whole number. And then we're going to square it, which gives us 9/4, and that's what we're going to add to both sides. All right, so if we're going to complete the square for x squared minus 6, what we're going to do, here's our x squared. Now I'm going to show it graphically, then I'm going to show it algebraically. And we know that we need 6 of these tiles. So when I take 6 of these tiles, I'm going to take 3 of them and put them along this direction. And then I'm going to take 3 of them and I'm going to go in this direction. And then the question is, how many of these little tiles am I going to need? Well, I'm going to need 9 of those little tiles. So that right here, this is our answer. We're going to add 9 to both sides. So that's our answer. Now, if we wanted to show that algebraically, x squared minus 6x. All right, so what you do is you temporarily ignore the sign and you say, well, we're going to take 6, we're going to divide it by 2, that gives us 3, and so that is what you're going to add. So you're going to add 3 squared to both sides. A lot of times algebra books will say, you know, what we really should be doing, let's see if I can go back. Okay, so since we know that the answer is 6 squared, 6 halves, so we're going to take the 6, we're going to divide by 2. A lot of textbooks just say, well, take that 6 half and square it so that it looks like this. So basically you take this number and you put it over a 2, and that's what you square. All right, and that's allowed as well. You're allowed to do that. And that's that answer. So what are we going to add to both sides? Well, we're going to add 3 to both sides. So now I'm just going to do this algebraically. We've got that x squared plus 5x. And what should be added to the expression to form a perfect trinomial? Well, we're going to take that 5, we're going to divide by 2. That cannot be simplified any further, so what we're going to add in is we're going to add in a 5/2 squared. And that's what we're going to put right here, but we need to simplify it a little bit. So what is 5/2 squared? Well, that's 25, 25/4. And that is what we're going to put in for our answer. So solving by completing the square is basically the same kind of idea. So I'm going to write the question for x squared plus 4x. I'm going to leave a little bit of a gap, and I'm going to get the 21. So I know that I'm going to take that 4, I'm going to divide by 2. Now that simplifies. That gives me 2. So then I'm going to take it, and I'm going to add a 2 squared. You always do that squared. Whatever this answer is, you square it. Always, always, always. So whatever I add to one side, I've got to add to the other side. And so this gives us, let's see, this gives us, well, I'm going to erase all this because I don't need all this. So I'm going to make all of that go away. All right, there we go. So now what they want us to do is they want us to solve. So that means we're going to then factor this. Now the whole reason we do this completing the square business is because this makes it easy for us to know that this automatically factors to x plus 2 squared. Now if you really want to see, well, we can go way over here and we can say, all right, well, x squared plus 4x plus 2 squared. Well, that simplifies to x squared plus 4x plus 4, plus 4. And then we can use our little box. And we know that x squared goes here. We know positive 4 goes here. So that means this is x and x. This has got to be 2 and 2. So that makes this 2x. This makes it 2x. Since we want these numbers to equal positive 4x, that means both of them have to be positive. So that makes both of these positives. So we end up with x plus 2 times x plus 2. Well, that's the same thing as x plus 2 squared. So that was a whole bunch of work to prove that this is equal to this. Now the right side is equal to 25 because 21 plus 4 is 25. All right. So now we see that this is something squared is equal to 25. So something, now we can use logic here. So let's go over here. So we know that we've got x plus 2 squared is equal to 25. So basically that's saying something raised to the power of 2 is equal to 25. What does this number have to be? Well, it has to be either a 5, because 5 squared is equal to 25, or it has to be a negative 5. So either of those answers, that's it. That's our answer. But we're going to go over here. So, by the way, what we would have done is use a comma. So we would have put 5, negative 5 to put in our two answers. But let's say we're going to keep going here. So what you're going to do here is you're going to say, oh, well, if we raise both of these to the exponent, a square root, the square root and the power of 2 are opposites of each other, so that they undo each other. So that leaves us basically that kind of like this cancels out with the exponent, leaving us with just an x plus 2, and that's equal to, and then over here this is either plus or minus 5, because positive 5 times positive 5 is 25, or negative 5 times negative 5 is negative 5, right? So, by the way, over here, no, I was wrong. Stinker. I was wrong. Okay, ignore the fact that I said 5s, okay? Because what I was saying, what I realized, is that the box is equal to 5. Well, the box was x plus 2. Remember, I kind of temporarily replaced it. So that means either x plus 2 is equal to 5 or x plus 2 is negative 5, because that's where the two answers are. Well, that means here x is either 3 or x is negative 7. So those are the answers that we're going to want to put way up here. Not that. It's going to be, what did I say? 3 and negative 7. So that's going to be 3 or negative 7. So now we're going to keep finishing this algebra. Boy, I'm kind of all over the place here. So what does this mean? Well, this means x plus 2 is equal to 5, or x plus 2 is equal to negative 5, because we have two cases here. So now you're just going to solve this algebra twice. You're going to subtract 2 from both sides. You get x is equal to 3. You're going to subtract 2 from both sides, and you get x is equal to negative 7. So that's our two answers. And that's what completing the square is all about. So the deal with completing the square, though, is that you need to have the problem in a specific format. So x squared plus 22x minus 6 equals 0. We need to get rid of this guy and move him over. So we're going to add 6 to both sides. So that leaves us with x squared plus 22x is equal to 6. All right, now I left a gap there on purpose because we now know what we're going to add right here. Because we're going to take 22, cut it in half. Oh, that equals 11. So we know we're going to add 11 squared to both sides. That's just the rule. And so now we automatically know that the left side factors to x plus 11 squared is equal to, and this is 127, because 11 times 11 is 121, plus 6 is 127. All right. So now what we've got here is we are going to square root both sides, because we know that the 2 and the square root undo each other. So that's going to be x plus 11 is equal to plus or minus the square root of 127. Because we know that this answer could either be a positive answer or a negative answer. And so now we're going to separate the cases. So it's going to be x plus 11 is equal to positive square root of 127, or x plus 11 is equal to negative square root 127. All right, so now using algebra, subtract 11 from both sides, so this gives us x is equal to negative 11 plus square root of 127. And then, or over here, we're going to subtract 11 from both sides, and you get x is equal to negative 11 minus the square root of 127, and those are our two answers. So you're going to have to put those up here in the box, separated by a comma. All right, so we are going to do the same things, completing the square. So we're going to start with x squared minus 9x, and I'm going to leave a gap here, is equal to 3. We know that 9 divided by 2 does not simplify, so I'm just going to leave it like that. I'm going to add 9 halves squared to both sides. So I'm going to add 9 halves squared to both sides. So the left side ends up being x minus 9 halves squared. That's what this factors to. It's this number that tells us what it's going to be. And the right side is equal to, oh my goodness, so that's going to be, let's see, 3 plus 81 fourths. So what is 3 plus 81 fourths? So let's see, 3 plus 81 fourths, that's really 3 over 1. So if we multiply both the numerator and the denominator by 4, we get 12 over 4 plus 81 over 4. And that equals 93 over 4. And that doesn't simplify. All right, so that equals 93 over 4, yeah. So we've got x minus 9 halves squared is equal to 93 over 4. So now we're going to square root both sides, because we know that the 2 and the square root cancel out. So you get x minus 9/2 is equal to plus or minus the square root of 93/4. Alright, so now we're going to separate this into two separate, well, what we can do is we can simplify this. So this is going to be plus or minus the square root of 93 over the square root of 4. That stays the same. And then right here, we know that the square root of 93, that doesn't help us. That's 331, no, yeah, nothing factors there. So, but down here, 2 times 2, square root of 4 is 2. So we know that this ends up being x minus 9/2 is equal to plus or minus the square root of 93 over 2. Oh my goodness. So now we need to write this twice. It's going to be x minus 9/2 is equal to positive root 93 over 2, or x minus 9/2 is equal to negative 93 over 2. Alright, so now we're going to add 9/2 to this side, add 9/2 to this side, and then when we do that, we end up with x is equal to 9/2 plus root 93 over 2. And that really simplifies to 9 plus root 93 over 2. So that's that answer. And then over here on the right side, we're going to add 9/2 to both sides. So we get x is equal to 9/2 minus root 93 over 2. And that simplifies to x is equal to 9 minus root 93 over 2. So these two terms, this term and this term, you don't need the x's, are what you're going to put in way up here. All right. Even students who get the answer correct, they often get this wrong because they type it in incorrectly. So be careful with that. We're going to solve by completing the square, and you'll notice they're kind of tricking us. It is not at all in the right format. We need this guy on the left, and we need this guy on the right. So let's accomplish that. So we're going to add 1 to both sides. That gives us x squared is equal to 4x plus 1. Then we're going to subtract 4x from both sides. And so that gives us x squared minus 4x is equal to 1. So what do we need? We need half of 4 is 2, so 2 squared. So we're going to add 2 squared to both sides. And that gives us x minus 2 squared. It's this sign that tells us it's a minus, is equal to 5. So now we can do the square root of both sides. So this 2 undoes the square root sign, so we get x minus 2 is equal to plus or minus root 5. And so now we're going to take that and we're going to write it as two separate equations. X minus 2 is equal to positive root 5, and x minus 2 is equal to negative root 5. So now add 2 to both sides. So that gives us x is equal to 2 plus root 5. That's 1. And then over here we're going to add 2 to both sides. So that gives us x is equal to 2 minus root 5. And that's the other answer. And once again, you're only going to put this portion in your answers up at the top in My Math Lab. So my goodness, look at all that beautiful work. And you're going to put those two answers right there. And lastly, a gross, big, ugly, scary looking problem. So you've got 196x squared plus 98x plus 3 is equal to 0. So first thing, this 3's got to be on the other side. But then also, we know that we need the x squared to be all by itself. So this 196 is problematic. So let's get rid of it. So the way we're going to do it is we're going to divide everything by 196. All right, and that's going to give us some fractions. So that's going to give us x squared plus, now 98 over 196. Let's go on some scratch paper. 98 over 196. Let's reduce. So divide by 2, that gives us, let's see, 49. 49 over, let's see, 98. And then can that, 7 goes into, yeah, 7 goes into both of those. So you get 7 over, and then 14. Oh, look at that. It's equal to 1/2. All right, so that whole thing, that's supposed to, yeah, it's all scary looking, but it's really, this is equal to 1/2 x. Now, 3 over 196, 9, 10, 11, 12, 13, 14, 15, 16, that does not simplify. So we would end up with plus 3 over 196 is equal to 0. All right, but that's not quite in the format we need, because we need to get rid of this guy and move him over. So that's going to be x squared plus 1/2 x is equal to negative 3 over 196. I subtracted from both sides, and that's how we get a negative over here. So what's half of a half? Well, half of a half is a fourth. So we're going to add 1/4 squared to both sides. So add 1/4 squared to both sides. So on the left side, we know from our rule that we end up with x plus 1/4 squared is equal to. Now this right side, we have to do some serious math here. So this is 3 and over 196, and this is going to be 1/16. So we need to do some scratch work. So let's do it over here. So that's going to be negative 3 over 196 plus 16. So what is our common denominator for 196 and 16? Oh my goodness. So I wish I had like a fraction calculator or something that would give us this answer, because gee whiz, this is just a gross problem. So let's see if I could find a common denominator. So let's see. Let's do, I don't know what our common denominator would be. Let's see if I can do that. So you're not going to believe this. This is just gross. The common denominator is 784. Gee whiz. So that's 784. So this is going to be times by 4. So that gives us negative 12. Now what the heck do we have to multiply? This is like times 49. That's how we get that. So that's going to be 49. So when we subtract, so 49 minus 12, that gives us 37. So this is equal to 37 over 784. So this is equal to 37 over 784. And now we're ready to do that square root thing. We do the square root thing. And let's see. The 2 undoes the exponent, the square root. So you get x plus 1/4 is equal to the square root of that ugly number. Now I'm going to see if square root of 784. Let's see, can we do the square root of 784? Let's see, 784, do the square root. Ah, that's awesome. So this is going to be the square root of 37 over. Now remember that this is square root of 37 over the square root of 784. Well, it just so happens that the square root of 784 is 28. There we go. So now we're going to separate this into two equations. 7 plus 1/4 is equal to, remember this is plus or minus, so positive root 37 over 28, and then x plus 1/4 is equal to negative root 37 over 28. And then so I'm going to subtract 1/4 from both sides, and so that gives me x is equal to negative 1/4 plus root 37 over 28. And then over here, I'm going to subtract 1/4 from both sides, and that's going to give me x is equal to negative 1/4 minus root 37 over 28. And technically we should be done. Both of these are correct, but it's possible that my math lab will want you to get a common denominator here, in which case we're going to multiply by 7 and multiply by 7, which gives us x is equal to 7 plus root 37 over 28. And then over here it's going to be negative 7 minus root 37 over 28. So it's possible they'll want this answer, but they also might want this answer, so I'm not entirely sure. By the way, I think this was supposed to be a negative sign right here, so that's got to be a negative 7. All right, so there you go, and that wraps up this video.